maybe I can stop and take a couple of those homework questions. That would be smart. So if you have your books. So as I look at 53, I have this picture right here. Can you find a place that it's not continuous? Where's a place that this function is not continuous? There's actually several.
3, 1.
At 3, I can see that there's what we call a jump, right? Because if they ask me, what is f of 3, I would say the answer is 1. F of 3 is 1. But notice here, in part C, they ask me for the limit. Maybe I should zoom in a little because that's too small for you guys to see. There's the picture. In part C, they say, what's the limit as I approach from the positive side? And in part D, they say, what about the limit itself? Well, what are you going to tell me about part D? Part D? Oh, part C is from the negative, part D is from the positive. Right. Are those the same? No. If I approach from the negative side, so part C, I'd say the answer is 1. We're approaching the value 1. But part D, as I approach from the positive side, I'm approaching that whole, which is 2. So part E, I'd say it doesn't exist. Guys follow that? Here, what about as we approach positive 1? That's an interesting question. G. So, first of all, what is f of 1? F of 1 is 2. That's why they put a dot there. F of 1 is 2. That's part F. But part G says the limit. It doesn't matter what f of 1 is. It says, what happens as x gets close to 1? What are the outputs getting close to when x is getting close to 1? Yeah, 3. You guys see that? So for number 53, I think that's an important distinction to make. In 53, when we have that situation in part F where they say f of 1 is 2, but part G, the limit as x approaches 1 of f of x is 3. Those aren't the same, right? And again, because as we get close to 1, the outputs are getting close to this whole, which is at 1, 3. All right? But here's the point 1, 2. And that's how I got part F. And so in this situation, I would say that the limit as x approaches 1 of f of x does not equal f of 1. Right? In other words, f of x is not continuous where?
At 1, 3.
We usually just say the x value, at x equals 1. Okay? Not continuous at x equals 1. So I think that's helpful. And then the only other question people were asking me is about number 65, the h. I'm going to work that one out here. And this is really related to what you do next time. So it said f of x is x squared minus 1. You guys got this? Okay, 65. And so the question said, evaluate and simplify f of 1 plus h. So f of 1 plus h, what that means is everywhere that it used to say x, what do you want to write? 1 plus h. So it's going to be 1 plus h squared minus 1. Okay? And my little trick from algebra, when I square a binomial, what kind of polynomial do you get? you better not get a binomial, or you did something wrong. You get a trinomial, right? Because we know that what that means is 1 plus h times 1 plus h, right? So you guys should have gotten 1 plus, well, h and h is 2h plus h squared minus 1. So it looks to me like f of 1 plus h is equal to 2h plus h squared. Okay, so that was part A. Now part B says try to compute this limit. Limit as h approaches 0 of, well, you'll notice that this f of 1 plus h is part of what we're computing. And then it says minus f of 1 all over h. Right? So I have to compute that. So I can say that that equals the limit as h approaches 0. And what do I have? I have, let's see. Well, I can replace that f of 1 plus h with 2h plus h squared. And then minus f of 1 all over h. You know, I never computed f of 1. I should do that. Let's do that up here. What is f of 1? 0, right? F of 1 is 0. So now this is kind of interesting, because what you have then, if that's really just a 0, you have the limit as h approaches 0 of 2h plus h squared over h. And what we're going to learn today is, you know, if you just substituted right now, you might think the answer is 0 over 0. Does that make sense? Why not? What's the problem? Is the problem having 0 in the numerator or having 0 in the denominator?
The denominator.
We know you can't divide by 0, right? But today we learn that this 0 over 0 is actually kind of special. It's called an indeterminate form. This 0 over 0, there's the word, indeterminate form. And so what it means to my calc students is we have hope. Maybe you can actually compute this limit. And it turns out you can, if you do the following. If you say, well, I'm going to do a little algebra. I'm going to factor out an h from the numerator. What would be left if I factored out the h? 2 plus h. Now, why did I factor out the h? I can cancel it. Right? You can cancel factors. And so now, this is the limit as h approaches 0 of 2 plus h. Now can I plug in h equals 0? 2 plus 0 is 2. So that's how that one works. Okay.